Good day, everyone. So, today we shall be looking at the topic satellite and semiconductors. All right, without much ado, let's dive into this topic. Now, when we talk about satellite actually are referred to as body orbiting a large object. Like you could see now, you can see this small body orbiting this large object. In this case, the larger object is the Earth. And most often, when we talk about satellite orbiting the Earth, we are talking about the artificial satellite. The artificial satellite are the one that orbit around the Earth, so it's just a body orbiting around the Earth. So the satellites are of two types: the artificial one, that is the one made by man, and the natural one. The natural one are actually the Earth and other planet orbiting the Sun. Okay, but we shall be focusing on the artificial one, and the artificial one have their different functions based on their purpose. We have the global positioning satellite. That one is for identification of location on the Earth. We also have the meteorological satellite. That one is for monitoring weather and climate pattern. We have the communication satellite. That is for transmission of telecommunication signals. Okay, and this various type of satellite, are designed based on the country. Like for Nigeria now, we have the Niger Sat 1 and we have the Nicom Sat 1 as well. So these are the two type of satellite that is made in Nigeria: Niger Sat 1 and the Nicom Sat 1. They are all artificial type of satellite, and these Niger Sat 1 and Nicom Sat 1 are from Nigeria. Alright, now let's talk about the component of a satellite. This is a typical diagram of a satellite. It consists of power generation and distribution system. It has protective shielding. It has rocket thruster system. It has payload. It has command and data handling system. The other components include the solar cells, the batteries, the command and communication antenna, the radio receiver, the transmitters, the rocket fuel, rocket motor, rocket thrusters, and the camera. So these are the part of satellite. These are the component of a satellite. Okay, let's talk about another area very important, and that is semiconductors. Semiconductors are actually materials with electrical conductivity between that of a conductor and an insulator. You see, it's between insulator and conductor. That's why it's called semiconductor. So it conducts electricity in between insulator and conductor. They are crystalline, solid, or sometimes amorphous solid with distinct electrical characteristics. Why are they having distinct electrical characteristics? That's because at higher resistance, they do not conduct well, but at lower resistance, they conduct better than the insulator. Okay, that's why they are distinct. Another thing that made them distinct is that as their temperature increases, their resistance reduces. Meanwhile, for conductors, as temperature increases, resistance increases. So that's why they are distinct. And the major example of this semiconductor are silicon and germanium. Now, when we come to this table here, we find out that semiconductor itself is divided into two types. We have the intrinsic semiconductor and the extrinsic semiconductor. The intrinsic semiconductor are the conductors that are pure in their nature. There is no impurity in them. But the extrinsic type are the type that are not pure. There is impurity in them. They have some impurity in them. And this impurity in them make us divide the extrinsic semiconductor into two. Now, the type of intrinsic will depend on the type of impurity that's in the semiconductor. Now, the deliberate introduction of impurities into semiconductor is called doping. Now, when you dope a semiconductor, it becomes either N-type semiconductor or P-type semiconductor. Doping actually helps to increase the number of charge carriers in a semiconductor. And the charge carriers we have in semiconductors are actually holes and electrons. Now, when we have more of electrons in a semiconductor than the hole, we call that semiconductor N-type semiconductor. And it is done when you add an impurity that is called donor. The impurity is of two types. We have the donor and we have the acceptor. Okay, now when we add an impurity called donor into a pure semiconductor, then the result gives us an N-type semiconductor. Sometimes we call these donor impurities, we call them pentavalent impurities. That's because they have XX electron. This pentavalent means 5 valence electron. So they are willing to release one so that they can have 4 and be balanced. While the other type of impurity that we add to give us P-type of a semiconductor is called the acceptor impurity, or sometimes the trivalent impurity. These ones have more of O. Okay, this O and this electron are the major charges we have. Okay, now when you introduce an acceptor impurity into a semiconductor, the result gives us a P-type semiconductor, meaning that the semiconductor needs more electrons, so it has shortage of electrons, and that's why it's called P-type. And the space where the electron will be is called the holes. Okay, all right. So this are a major introduction that we need to know about semiconductor in physics. Thank you for listening. Till I come your way again, have a wonderful day. Bye for now.